I don't ever want to see you kicking out a methyl group as a leaving group. As you work your way through organic chemistry, you're going to come across mechanisms where you kick out a leaving group. What does it mean to be a leaving group, and how can we tell which functional groups can act as competent leaving groups? Let's find out. As you look at various molecules in this course, you will see lots of functional groups attached to those molecules. Some of them can be leaving groups, some of them cannot. To figure out what makes a good or a bad leaving group, let's take a look at what they would look like after they leave. If an iodide were attached to your molecule, the bond would break, the electrons would go onto iodine, and it would leave as I-. Take a second, pause the video, see if you can finish the rest of this list. What would each of these groups leave as should they be a leaving group? When these bonds break, and when these leaving group leave, they will leave with their lone pair of electrons to form the leaving group. We have various halides as leaving groups. This leaving group you may not have seen yet. It's called a sulfonate. It's a very common leaving group in organic chemistry. There are a couple of different flavors of sulfonates depending on what this R group is. It might be a methyl group, it might be a benzene ring, or something different. Whatever the R group is, the bond breaks and the oxygen gets a lone pair that can be stabilized through resonance. OH2+ leaves as water, NH3+ leaves as ammonia, OH leaves as OH- hydroxide. This group leaves as a carbon negative charge that's resonance stabilized. You also may not have encountered this yet, that's okay. It is called an enolate. To round out our list, an amine leaves as NH2-, a hydrogen leaves as a hydride, H-, and an alkyl group leaves as a carbanion. This is what would happen if all of these were potential leaving groups. What we notice as we do reactions with these functional groups is that the groups at the top of this list are leaving groups now in substitution and elimination land. The leaving groups in the middle aren't leaving groups now, but they will be leaving groups later when we get to carbonyl land. And these leaving groups at the bottom are never leaving groups. I don't ever want to see you kicking out a methyl group as a leaving group. But why? You can memorize this list, but why? What I notice about the groups at the top of this list is that once they leave, all of these are weak bases. And all of the groups at the bottom of this list, when they leave, are very strong bases. Why do weak bases make the best leaving groups? Why are the best leaving groups weak bases? Weak bases and leaving groups share a lot of the same desirable properties. Weak bases are very unreactive, they're very stable, they can handle excess electron density well, and they don't mind being off on their own. That's exactly what we want in a leaving group. When the bond breaks and that group leaves, we want it to be stable, unreactive, able to accept a pair of electrons, and be happy off on its own. That's why weak bases make the best leaving groups. Here in the middle of the table, these groups are somewhat stronger bases, and they will leave, but only when you give them a little energetic push. You need a little delta H boost, a little energetic kick to kick out these leaving groups that weren't quite good enough to leave in substitution and elimination land. And these groups at the bottom are so unstable that they'll never be able to be leaving groups, at least not in this course. So when you're going through your mechanisms and you notice a potential leaving group, you now know if it's a competent leaving group that you can continue on with the mechanism, or if it's a bad leaving group and the mechanism cannot continue.
Thanks for watching. The best way you can support this channel is to let your friends know about these videos, especially ones who go to different schools. Help spread the word around the country. As always, don't forget to like and subscribe.